Students, by now we know that sound is produced by vibration. So that's clear. Now the question is, how does sound propagate? What do we mean by propagate or propagation? The term propagate refers to spreading something. That means to spread or to get transmitted. So, how exactly do you think that sound is getting transmitted from one place to another? First of all, do you think that sound is getting transferred from one place to another? Yes. Just look at this example. When you talk to somebody, let's say you are in a conference room or you are in a meeting and some people are staying there. Now, when one person speaks, all the other people are able to listen. So that means the sound produced by one person, sound produced by speaker, is produced by his larynx. But that means this sound is traveling in some way so that it is able to reach the ears of the listeners. That is why listeners are able to hear it. That means sound is traveling in some way. So the question is, how does sound propagate? Now, it's not only that you are present nearby to hear each other, sound is also able to get transmitted over long distances. For instance, when an aeroplane is flying high in the sky, you are able to hear that noise of the aeroplane, right? Similarly, if there is a train which is quite kilometers away from you, but still you are able to listen to the whistle of the train. So, have you noticed that these kind of sounds, which are produced by one source, is heard by quite a number of other people? That means it is able to get transmitted over distances. So, now the question is, how is sound traveling from one place to another place? So, sound always needs a medium for propagation. That means it needs some medium through which it can travel. Now, you might ask, what is this medium? So, let's try to understand the meaning of medium. What is it trying to tell is, let's look at this scenario where there are two persons, they are talking to each other. Now, when one speaks, the sound is actually getting transmitted up to other person. Now the question is, does sound need something to travel from person 1 to person 2? So yes, sound needs a medium. Let's see what's a medium. Now first let me give you some examples so that you know what is medium. When you think of vehicles on road, any sort of vehicle, right now tell me, how will the vehicle run? Where will you drive the car? You need a medium, right? So your car is not flying in the sky. Your car needs a road. It can only travel on a road. So the road is the medium on which the car can travel. Let's take the example of a ship or a boat. Do you think that it can move from one place to another itself? No, it again needs a medium. So what is the medium for this boat or ship to travel from one place to another? The medium is the water. If you think of an aeroplane, what is the medium for an aeroplane? Where can the aeroplane move from one place to another? It needs the medium, and the medium is air. So now are you able to understand what is the meaning of medium? Medium, it's a base on which a particular object can move from one place to another. It's a base, okay? So in a very similar way, how you have the car or an aeroplane or the ship here, similarly sound also wants to travel from one place to another, and for that this also needs a medium. So what is the medium for sound? What kind of medium does sound needs? It needs water, air, or what does it need? So that's what we will see here. So, how can we define medium now? Medium is nothing but an object through which sound is transmitted. So, what could be this object now? What could be this path now through which sound is transmitting? Now, this object, this medium can be solid, can be liquid, or even be can be gas. That means sound can travel through solids like wood, metals. Solids, sound can travel through liquids like water, it can travel through gas like air. All these objects through which sound gets transmitted, these objects are called as mediums. So, as I said, medium could be a solid, liquid, or gas, but a medium is required. So, something has to be there. Now, you might ask, what do we mean by medium has to be there? So obviously everywhere there will be either air or water or some other substance. So something will always be there. But that's not the case. We can even create an atmosphere or an environment which is completely empty, which doesn't even have air, nothing in there. And that's known as vacuum. So sound cannot travel in vacuums. Now we'll talk about vacuum. So, many of you might be getting this term vacuum for the first time. So, let's try to understand what is a vacuum. It's a space which is completely devoid of matter. And matter, what is matter? Matter means anything that occupies space. It can be solid, liquid, gas, everything falls under matter. Now, let me give you a simple example to explain what is matter. Suppose you have a bottle and it's filled with water. Will you say that the bottle is empty? No, because the bottle is already filled with water. So, right now, what do we have inside the bottle? You have liquid inside the bottle, you have matter inside the bottle. Now, you take out water which is present inside the bottle. So, if you have taken it out, now will you say that the bottle is empty? Yes, many of us will say that yes, the bottle is empty because because there is no water inside the bottle. But if I ask you, is there anything or matter present inside the bottle? So yes, of course, there is some matter present. That is air. Air is present inside the bottle. The moment air is present everywhere around us, right? So the moment you take out the liquid from the bottle, even before you can put the cap on the bottle, air enters inside. So air is still inside the bottle. So now also the bottle has matter. Now there are techniques by which you can take out even the air from the bottle. Then what do you say? The bottle is completely devoid of matter because now it doesn't contain any liquid, it doesn't contain any gas, nothing is there. Then we say that a vacuum has been created inside the bottle. So that is vacuum. Vacuum means absolutely nothing, no matter at all. Now you might be thinking that it might sound something imaginary to you, that something like a vacuum also exists. Or how do we create vacuums? Now, as you go to your senior classes, you will learn about various methods by which you can create partial vacuums or you can create vacuums. Here we will not go in that much detail, but yes, it's not an imaginary concept. It is possible to create vacuums, complete emptiness inside an object. I will give some of the examples which you see around yourself where you can feel vacuum to some extent. One such example is a magic which is often shown to kids, but it's not actually a magic but a simple scientific phenomena. All you need to do is take a glass, fill it with water up to the top. Now you place a paper card over it. As soon as you place a paper card over it, you quickly turn the upside down as shown here. Now, as soon you turn it upside down, what do you expect to happen? Normally, we expect that the paper card should fall down and the water should also fall down, but you will see a magic. What happens even when you turn it upside down, the paper card sticks to the glass. So it's like a magic. The water is still there inside the glass, and the paper card is still stick to it. There is simple science behind it. What happens? A low pressure area or partial vacuum, you can say, is created. And due to the creation of this partial vacuum, now where is this partial vacuum created? The As we are expecting what that paper card will fall because the weight of the water will push the paper card downwards, and that is why the paper card will fall and water will also fall, right? But that's our expectation. But what happens just between these two layers? You have water and paper cup. Between these two layers, a very thin layer of vacuum is created. Vacuum means some where there is nothing. So this vacuum acts as a separation between water and paper card. So the water is not able to push the paper card, and that is why paper card is not falling down. So that is the simple logic. Another example where you can see the partial vacuum, suction pumps, or you can say suction caps. Have you ever seen these type of caps? You often use it for hanging stuffs. They also have these kind of suction caps, and what happens to them when you stick them to a smooth surface? They get stuck very tight, and then it becomes very difficult to bring them out. So why are these caps being able to stick to a smooth surface so tightly? That is also due to the creation of vacuum. So the inside space has vacuum. There is no air inside, so it becomes airtight. And you would have heard the term airtight quite often. These days, there are so many containers. They say that they are airtight containers. If you keep food materials inside, air will not be able to enter. So that's how they will not get food will not get spoiled and all that. So I hope you would have understood now what is vacuum. Now we were talking about the propagation of sound. If sound wants to travel from one place to another, it needs a medium, and it cannot travel in vacuum. One very popular experiment, which is known as Bel Jar Experiment. This experiment shows that sound cannot travel in vacuum. What I mean by this, it means if sound is produced from some source, other people will not be able to hear it if it's all vacuum, because sound will not be able to get transmitted from the source to listeners. So here is this experiment. I'm having an apparatus here, having a bell jar, and this jar is connected to a vacuum pump. The purpose of this pump is to create vacuum inside. It will take out all the air from the bell jar. So inside this bell jar, you have a vacuum. Then we have in it electronic bell, and the switch is somewhere outside. What we normally expect, if we switch on the bell, it will ring, right? In normal, say when doorbell rings, you hear the sound because it travels through air. But here, when we switch it on, the bell rings, but you are not able to hear it because it's all vacuum inside. So the sound is not able to travel from source. That is why nobody is able to hear this sound of a bell. This experiment proves that sound cannot travel through vacuum. Sound needs a medium to propagate, and this medium could be a solid, liquid, or gas.